Hi, my name is Naya Wu, and I'm doing a presentation for Lab 1, Charge Tapes for Physics 2212. For the introduction overview, our purpose of this lab is to solve for the amount of electric charge on charge tapes. And by doing so, we will be able to understand and explore the phenomenon of charge. For example, Coulomb's law, electric fields, and point charge. For the result, I ended up getting that one piece of clear tape has a charge of 1.74 times 10 to the negative 9 coulombs. So to make the charge tape, what we needed to do was to stick a base tape onto a surface. Then you put another U-tape on top of the base tape, and then you quickly rip off that U-tape off the base tape. By doing so, it charges the U-tape. For this experiment, you need to make two U-tapes. And through some observations, we noticed that the U-tape is positively charged. For example, when you interact two charged U-tapes, they end up repelling each other. When you interact a U-tape for a neutral object, it ends up attracting to the neutral object. And when you interact the U-tape with a charged plastic pen, they end up attracting each other. So it's concluded that the U-tape is positively charged. For the procedure, what you needed to do was to hang the tape charge B to two objects so it hangs like a bridge. And then what you end up doing is you put tape A underneath tape B, and since they repel, tape B will float up a bit from the repulsion. And because of this, we can measure that difference between tape B's original position and tape B's position after the repulsion to find the charge. Some assumptions and fundamental physics principles we need to know was that A, atoms are equally distributed through the tape. B, every atom has an equal predisposition to lose electrons. And C, to treat the U-tapes as a single point charge. In terms of the principles, we need to use these four formulas. So the Coulomb's law, the electric field equation, the force on charge object equation, and the force of gravity equation. So first, for the calculations, we need to calculate the magnitude of the gravitational force on tape B. We measured the length of tape B, which was 17.2. We converted to meters, and since the tape weighs 1 gram per meter, we were able to find its mass. So it was 0.000172 kilograms. And using this mass, we were able to solve for its gravitational force, which was 1.7 times 10 to the negative 3 newtons. Now, using this number, we can find the charge through Coulomb's law. So in the second calculations, we measured the separation distance, which was 0.004 meters. And since we also know the force of the charge, we can plug everything in to find Q. So 1.74 times 10 to the negative 9 coulombs. Afterwards, we can find the number of corresponding electrons on tape B. And to do so, we need to divide 1.74 times 10 to the negative 9, so the charge of the tape, to 1.6 times 10 to the negative 19, which is the charge of the electron. And what we end up is 1.0809 times 10 to the 10 electrons. Through glow script, we can still see the same thing. Our distance is 0.004. You can see the mass of tape B. You see the two objects, so tape B, tape A. You can see that they're repelling. And you can see our calculations here. So the force of gravity, you multiply the mass times gravity. Force of electron, or the force of the electron, yeah. It's just negative. And all these other calculations, which ends up getting us the same deal. The charge present in each tape is 1.74 times 10 to the negative 9, and that the number of electrons was 1.08 times 10 to the 10 electrons. So for questions, what if the electrons had a positive charge and protons had a negative charge? What would change? Nothing will still change since they will still repel as tapes, and since they're still the same charge, maybe they'll interact a little differently with the pen, but with the table, with everything else, it should be the same. Why is it important to handle these charged tapes as low as possible? the reason why you need to handle it as low as possible is because the charge tapes have an deficit. So if you touch these tapes, electrons from your hand will travel to the tape and will make it neutral again, which thus ruins what we need to calculate. And yeah, so that's it. Thank you for listening.